We're back in school. I'm so happy to have had a whole entire day with you guys without a late start. It was wonderful. Just so excited to get back into the swing of things. We are getting into lesson 8. I think you guys are going to actually really love lesson 8 because we are going to start kind of leaning into standard algorithm. We're finding fractions of whole numbers, and we're going to temporarily kind of leave our modeling behind. Again, modeling is so helpful. It really supports our understanding, but we don't need to be modeling for the rest of our lives. Model, 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 model. Okay, yeah, now I kind of understand what's going on here. I think I'm ready to leave the models in the wings. We're going to think theatrically about this. And now we can just kind of dive into finding fractions of whole numbers numerically. And like most things, we're going to start with like some really basic E-word numbers. Just really take this one step at a time. We're going to look at finding fractions of whole numbers in 2 different ways, just because it's nice to have some options in life. And it's going to be great. We're going to do all of the problems twice. Like I said, we'll do them in 2 different ways. So just take your time, be patient with yourself, and let's get going. Here we go, guys. Okay, buds. So here we are, as you guys know, in L8. And we're going to take a look at these expressions in a few different ways, kind of like I said in our intro. So let's look here first. Rewrite the following addition expressions as fractions as shown in the example, or like they're shown in the example. Okay, so here's the example. So we have 2/3 plus 2/3 plus 2/3 plus 2/3. We're going to rewrite that as multiplication. How many 2/3 do we have? Well, we have 4 times 2/3. That's equal to 8/3. Okay, so let's try a few of these. So here in A, we have 7/4 plus 7/4 plus 7/4 equals, well, how many copies of 7/4 do we have? We have 3 copies of 7/4. 3 copies of 7/4. That is equal to, well, multiply 3 times 7, that's 21. 21, and then what do we have at the bottom? We have 4. That's going to be the denominator. I want you to think about something else. This can be done in a bunch of different ways. Something else that we can do is consider this. I'm just going to do this here off the side. 3 can be rewritten as a fraction really easily. 3 is equal to 3/1 because 3/1 is equal to 3 divided by 1. And what is 3 divided by 1? That is 3. So at any point in your life, you can rewrite any whole number as a fraction just by simply putting it over 1. Okay? So let's look at this first one a little bit in another way. So yes, we have 3 copies of 7/4. We can also rewrite this as 3 copies of 7 and put everything over 4, right? Because what we're essentially saying here, you guys, is 3 can be rewritten as a fraction if we put it over 1. So we're looking at 3, or 3/1 times 7/4. That's all we're doing here, you guys. 3 copies of 7/4. If you want to rewrite 3 as a fraction, just put it over 1. 3/1 is the same as 3. Now, what we need to do, since we're multiplying technically here 2 fractions, let's look at what's going on upstairs. Well, upstairs in the numerators, we're looking at 3 times 7. Okay? What's going on downstairs? Downstairs, what we're doing is multiplying 1, here we are, by 4. if you wanted to simplify this a little bit, we could look at 3 times 7 just over 4, because 4 and 1 times 4 are the same thing. Do you guys see how we can do this in so many different ways? Because the beauty of math is that we can represent numbers in a multitude of ways. Okay, so just be very aware of the work we're doing. We're kind of doing some math magic here. We're rewriting these expressions as multiplication expressions, but just please know, you guys, that we can do that in a few different ways. Okay, let's take a look. Let's look at this one as well. So here, you guys, we have 1, 2, 3 copies of 4/7. We can write that as 3 times 4/7. That works. Or we can write it as our numerators. I'm going to draw a little line of learning here so they don't merge into each other. What's going on in our numerators? Well, numerators are 3 times 4. We can draw that over a giant fraction bar. And what's going on downstairs? You guys know that any whole number can be rewritten as a fraction if we just write it over 1. But that doesn't necessarily have to happen. We can also just skip that, and we can just see that our numerator, the only number there, is 7. If you wanted to, you guys, I'm sorry if I said numerator, I meant to say denominator. This is that denominator, the downstairs number. We can write it as 7, or we can also write it as, if you wanted that 1 there, you could also write it as 1 times 7. But you guys know that 1 times 7 is 7. So it's really not necessary, you guys, to have this 1 times 7. It's easier just to have our 7. So the way that we can rewrite 3 copies of 4/7 is in this way: 3 times 4/7. And what is 3 times 4/7? Well, 3 times 4 is 12. And so what we end up having is 12/7. Absolutely an improper fraction. We're not even going to think about simplifying that right now. I just really want you guys to think about how we can rewrite these repeated addition expressions as multiplication. And then we just simply evaluate whatever multiplication is going on here in the numerator. And then we can rewrite that as 12/7. So this really is just an exploration. Let's take a look at some more examples, guys. Next up, we are looking to solve each problem in 2 different ways as modeled here in the example. Okay, so here's our example. I put this sort of in a quadrant because you can see that these are the problems that we're doing in 2 different ways. I just wanted to make sure that our space was organized. Okay, so for example here, you guys, we have 6 times 2/3. We're rewriting it, as you can see, in a few different ways. 6 times 2/3 equals 6 times 2 on the top over 3. That is equal to 3 times 2 times 2. We're just kind of decomposing what we have in the numerators, and then we're evaluating it. Okay, so let's look at this one here, you guys. We have 14 times 3/7. Well, that is equal to, up top, 14. Oh no, I hit the button. 14. I hope I didn't. This darn button on my pen. I need to be more careful. So, I did do that. I don't want this fancy tool. Okay, 14 times 3/7. What is that equal to? Well, up top, we're looking at 14 times 3. Down below, we have 7. And now we're going to decompose that. 14 times 3, that's actually equal to, we're going to decompose 14 into 2 times 7. Okay, cool. So that's equal to 2 times 7 times 3. We're just kind of ripping that apart. And this is still over 7. And now let's go ahead and evaluate that. Well, I know 2 times 3 is 6. 6 times 7 is 42. And what do we have as our denominator? We still have 7. 42 over 7, you guys know this, is equal to 42 divided by 7. And my friends, what is 42 divided by 7? Well, hot dog, it is 6. Okay, let's look at it another way. Here on the right side, you guys, what we're going to be doing is simplifying. So let's look at the example here. 6 copies of 2/3 is equal to, up top, 6 times 2, before it was simplified, down low is 3. And then there's some simplification that went on. So let's do that here, you guys. 14 times 3/7 is equal to 14 times 3 up top. And then on our denominator, you guys, we have 7. Let's look at this now. This really means 14 times 3 divided by 7. We can actually simplify this 14 and this 7 because 14 over 7, we can divide 7 by 7 to make it a 1. We can divide then also 14 by 7, which becomes a 2. So we're actually simplifying these expressions here on the right side before we evaluate. Now what we're looking at, you guys, is 2 times 3 after we simplified. And what do we have down low on the denominator? 1. 6 over 1 is equal to 6. As long as we have the same final answers, we are golden. So, same final answers for both sides, but as you can see, our approach here on the left side was much different than our approach here on the right side. We're simplifying on the right side. Left side, we're really just decomposing and rewriting the expressions so that we can evaluate them mentally. Okay, so let's try it down here, you guys. Here we're looking at 32 copies of 9/8. So let's rewrite this. So what that really looks like, you guys, I want you to recognize the fact that 9/8 times 32 is equal to 32 times 9/8. I want these to be written in the same format, just so we can have this consistency as we are just kind of starting off here. I'm going to erase this. You guys kind of see my magic behind the scenes work. Okay, so we're looking at 32 copies of 9/8. So let's go ahead and rewrite that as what's going on our numerators. Well, that's 32 times 9. And then our denominator, you guys know, is 8. Let's go ahead and decompose this a bit, shall we? We can decompose 32 into 8 times 4. Okay, very well. We can also decompose 9 into 3 times 3. So let's go ahead and stretch that out and really decompose those numbers. So 32 times 9 can be decomposed into 8 times 4, that was this one, times 3 times 3. That was the decomposition of 9. And then this is still over 8. Okay, let's try to go ahead and evaluate this in our head. Well, I know 4 times 3, I'm going to cross these out as I evaluate them, are 12. I know 3 copies of 12, think about it, 3 copies of 12 is 36. And then 36 times 8, I'm afraid to tell you, well, actually I'm not. I'm proud to tell you that I don't have that in my head, so I'm just going to go ahead and do that really quickly up here. 36 times 8. 6 times 8, 48, my favorite multiplication fact. 8 times 3 is 24, plus 4 is 28. So what we're looking at as the denominator, you guys, is 288. And our numerator remains to be our 8. Okay, now let's go over here. This is not simplified. You know what? Let's simplify this because over here that version is going to be much more simplified. Let's check out what 288 divided by 8 is. okay, using long division. 8 goes into, let's look at this 28 first, 3 times with some left over. 3 times 8 is 24. The difference between 20 and 24 is 4. I'm going to bring down that 8. Oh, hot dog. 8 into 48. How many 8s go into 48? Well, I know. 6 times 8 is 48. And that's very good news. We don't have a difference here. Okay, so this ultimately, 288 divided by 8 is 36. Okay, so left side again, you guys, decomposing numbers, trying to do as much as we can mentally, but I mean, we're not machines, so don't be afraid to do some scratch work. So over here, we're going to simplify. So we're looking at 32 times 9 upstairs, and then we have 8 downstairs. So when we're looking to simplify, I'm analyzing all of these numbers, and I'm thinking, can I divide any of these numbers by a common divisor? And I'm looking, 32 and 8. I can divide 32 by 8 and get 4, and I can divide 8 by 8 and get 1. See what's happening here? Now, upstairs, all we need to look at is 4 times 9, which is 36. Downstairs, my friends, we have a 1. 36 over 1 is 36. Is that the same number we found over here? Indeed. Sometimes this left side work is going to be more efficient. Sometimes this right side work is going to be more efficient. In this case, for sure, this was our more efficient side. Let's take a look at just a couple more examples here, guys. Okay, just a couple more here, guys. Here we are told that we can solve each problem any way you choose. Aha. So here we're looking at 1/3 of 60. So what that really means, you guys, is 1 times 60 over 3, which equals, well, 1 times 60 is 60. What we're looking at, low battery, of course. What we're looking at, you guys, is 60 divided by 3. 60 divided into 3 equal groups. Sorry, I'm running to get my charger. 60 divided into 3 equal groups. Well, let's simplify that a little bit. Let's think about 6 divided into 3 equal groups. 6 divided into 3 equal groups is 2. So 60 divided into 3 equal groups, my friends, is 20. Don't believe me? Just think about 20 times 3. Yep, that's 60. So 1/3 of a minute, that doesn't make any sense. 1/3 of a minute is not equal to 20 seconds. 1/3 of a minute equals 20 seconds. 1/3 of 60. Yeah, that's right. Sorry, guys. That took me a second. 1/3 of a minute is equal to 20 seconds because if we had this pie chart broken into 3 equal pieces, 1, 2, 3, and we had, if the whole represents 60 because there's 60 seconds in a minute, if we were just to look at 1/3 of a minute, yes, that would be 20 seconds. I needed to check in with my logic there. Let's take a look at this, since we were talking about powers of 10 here at the end of the day. Here we're looking for 7/10 of 1,000. What that means, you guys, is up top we're looking at 7 times 1,000. And then what we have on the denominator on the bottom is 10. So 7 times 1,000, or 7 times 1 is 7 with 3 zeros. The denominator is 10. We know how to do 7,000 divided by 10. Oh, place value chart. Where would I be without you? Let's go ahead and put 7,000 on our place value chart. And let's think about what happens when we divide something by 10. When we divide something by 10, we're going to move to the right on our place value chart. We're dividing by 10, so each of these place values is going to hop over one column because 10 has a 1 0 in it. So let's shift everything over to the right one column because we're dividing by 10. And what we're going to end up with is 700. 7,000 divided by 10, you guys? 700. And then I just want to look at this one down here. This reminds me of what we were doing a little bit in science at the end of the day. And here we're looking for 3/5 times 100. Upstairs, we have 3 times 100. Downstairs, we have 5. Let's go ahead and evaluate this. 3 times 100, you guys know, is 300. And we have 300 over 5. Let's attempt to do this in our head. 300 divided by 5. Well, I know 30 divided by 5 is 6. So 300 divided by 5 is 60. Let's just check in with logic and make sure that 60 times 5 is 300. Well, 6 times 5 is 30, and then we're bringing 1 0 along. Cool. So tomorrow we will work on all of this amazingness. Now you can see we are just really exploring these expressions numerically. Sometimes we're supporting these thoughts and ideas with pictures, but just know moving forward, we're really just going to be crunching the numbers. So secret word for tonight, you guys, is going to be I think that term crunching the numbers. Secret word for you to check in the morning is going to be the term crunching the numbers, because that's what we're going to be doing moving forward. Can't wait to have another great day with you guys tomorrow. I will see you then.